Good morning, class 12 science. We're doing the chapter surface chemistry, and we're seen in the last class about the colloids and its classification. Now, today we are going to see in the classification, we also have classified colloids as lyophilic and lyophobic, if you remember. So, now today we'll see the preparation of lyophilic colloids. So, lyophilic colloids. Lyophilic means solvent loving. So, hydrophilic colloids such as starch, gum, gelatin, etc. form colloidal solution when warmed or left in contact with water for a long time. So, you can prepare hydrophilic or lyophilic solution, colloidal solution, by warming or left in contact with water such as starch, gum, or gelatin. These particles are already of colloidal size and they readily disperse in water, forming colloidal solution. Salts of water insoluble high molecular weight may be similarly obtained by the dispersion in suitable liquid. So it's very simple to prepare lyophilic salts. We just need to add the substance in the water or warm it. Next, preparation of lyophobic colloids. Okay, so we have got various methods for the preparation of lyophobic colloids. The first is dispersion method, and this is known as electrical dispersion or Briggs arc method. Okay, now this method is employed to prepare salts of metals such as copper, silver, gold, or platinum. So this method is used to prepare the colloidal solution of metals like copper, silver, gold, or platinum. Now, in this method, the metal whose colloidal solution is to be prepared is made as two electrodes. This two electrode, okay, whose colloidal sol you want to prepare. The electrodes are immersed in dispersion medium. Okay, the electrodes are immersed in dispersion medium such as water. The dispersion medium is cooled by immersing the container in an ice bath and a trace of alkali is added. An arc is struck between the metal electrodes held close together. The tremendous heat generated by the spark across the electrode vaporizes some of the metal and the vapors condense immediately in the dispersion medium to give colloidal solution. The trace of added alkali helps to stabilize the sol. Okay, now what will happen? So this is the arrangement. So when an arc is struck between the two electrodes, there is generation of tremendous heat that will vaporize this electrode's metal, and it will be vapors will be condensed by the dispersion medium, that is water over there. So it will form a colloidal solution. Next, number 2 is peptidization method. Peptidization means the process which involves the conversion of freshly prepared precipitate into colloidal solution by the addition of suitable electrolyte is called the peptidization. So the process in which we can convert a freshly prepared precipitate into colloidal solution by the addition of electrolyte, suitable electrolyte, we can call peptidization. The electrolyte added is called peptidizing agent or dispersion agent. Okay. For example, if freshly prepared ferric hydroxide precipitate are treated with a small quantity of ferric chloride electrolyte solution, a dark reddish brown colloidal solution of ferric hydroxide is formed. Okay. This is an example of peptidization. Other methods we have got oxidation. Say for example, hydrogen sulfide when treated with sulfur dioxide, it will form colloidal sol of sulfur. Similarly, H2S can react with bromine to give you colloidal solution of sulfur. Okay. In reduction, we have got when EuCl3, that is gold chloride, okay, it is stannous chloride, it is going to form the colloidal solution of gold, Au. Okay, that is the reduction. Next, purification of colloidal solution. So we can purify the colloidal solution by different methods: dialysis, ultrafiltration, ultracentrifugation. So these are the three different methods through which we can purify the colloidal solution. Properties of colloidal solutions: brownian moment, dindle effect, coagulation, electrophoresis, protection of colloids, Coulomb number, and emulsion. So these are the important properties of colloidal solution. So first we'll discuss about brownian moment. Brownian movement means the rapid motions of colloidal particles in a zigzag way. We call it a Brownian movement. It has been observed through ultramicroscope that in colloidal solutions, colloidal particles are in constant and rapid zigzag motion and rapid zigzag motions called Brownian movement. The phenomenon was first observed by Sir Robert Brown in 1827. Next, Tyndall effect. It's a very important effect. Now, to understand Tyndall effect, you have to observe a phenomenon in a practical life that we have seen. Say, for example, it has been noted that when a beam of light enters a dark room, okay, it lights up the dust particles floating in the air. Similarly, when a strong beam of light is passed through a colloidal solution, the path of the light becomes visible when viewed from a direction at right angles to the incident light. Okay. Now, so when you are dark room and say for example if there is a hole somewhere and light is coming from that part, so if you observe the path of the light, you can see the dust particles in that will be floating around, sparkling and all. Okay, so a similar kind of effect also occurs in a colloidal solution. Okay, so when a strong beam of light is passed through a colloidal solution, the path of the light becomes visible when viewed from a direction at right angle to that of the incident light. This is due to the fact that colloidal particles absorb light energy and then scatter it in all directions. So the phenomenon of scattering of light of colloidal particles is called as a Tyndall effect. So say for example, if this is a source of light, when it passes through the lens, light being visible. Through true solutions it is not visible, but when it passes through a colloidal solution you can find the scattering of light. Next process is coagulation. The process by which the colloidal particles come closer and result in the precipitation of the colloidal particles is called coagulation. So the process by which the colloidal particles come closer and they can result in the precipitation called coagulation. The coagulation or precipitation of a sol can be brought about in 5 different ways as follows. Number 1, by addition of electrolytes, by mixing two oppositely charged sols, by boiling, by electrophoresis, and by persistent dialysis. Next, Haddy-Chuli's rule, called very important rule. What does it say? It states that the higher the valency of the flocculating ion, or we can call coagulating ion, the greater is the power to cause coagulation. Thus, for precipitating an arsenic sulfide, that is negative, the precipitating power of positively charged ions is in the order of aluminum 3 plus greater than barium 2 plus than sodium. So, according to this rule, it states that when the valency of the fluctuating ion higher, there is a greater power to cause coagulation. Next, protection of colloids. The property of lyophilic colloids to prevent the precipitation of lyophobic colloids by electrolytes is called protection. So, the property in which lyophilic colloids can be prevented for undergoing precipitation reaction by adding electrolyte, we call protection. The lyophilic sol used to prevent the precipitation of lyophobic cell is called protective colloid. The protection action of different colloids is expressed in terms of gold number. So this protection action is expressed in gold number, whereas gold number we can define as the number of milligrams of a hydrophilic colloid which just prevent the precipitation of 10 ml of gold solution on the addition of 1 ml of 10% sodium chloride solution. So gold number basically defined as the number of milligrams, how many milligrams of hydrophilic colloid will be able to just prevent 10 ml of gold solution by the addition of 1 ml of 10% of sodium chloride solution, that is electrolyte. Now today's assignment 12. Question number 1, mention 3 methods for the preparation of lyophobic colloids. Question number 2, what is Tyndall effect? Question number 3, define coagulation, mention the ways to bring about this process. Question number 5, state Haddy rule. And question number 5, define gold number. So complete this assignment and send it in my mail.